Apollo 13 was the third manned lunar landing mission, part of Project Apollo under NASA. The flight commander was James Lovell, the command module pilot was Jack Swaggart, and the lunar module pilot was Fred Hayes. The mission was scheduled to explore the Frau-Morrow Highlands and craters within the Frau-Morrow Highlands. Flight problems began early when the centre engine shut down 2 minutes early due to pogo oscillations. However, this was nominal to the two missions, and the launch into port were carried on as planned. After the translunar injection burn, when the spacecraft was 200,000 miles away from Earth, Mission Control requested that the crew stir the oxygen tanks. This caused a catastrophic explosion where the number 2 oxygen tank contained in the service module exploded, critically damaging both oxygen tanks. Because the command service module relied on oxygen to generate electricity, this meant a drastically reduced amount of power for the Apollo 13 crew. The mission was for all intents and purposes a successful failure. However, there are some people out there who are convinced Apollo 13 shouldn't have been able to get back to Earth at all. This is Jarrah White, and he's a self-proclaimed grandson of the Apollo hoax theory.
This means that the surface engine, which had no throttle, burned 2 tons of fuel per minute. Therefore, the burn to acquire lunar orbit normally required a minimum of 12 tons of fuel. That's 24,000 pounds. According to NASA, lunar orbit was attained by using the LEM's engine. Since the LEM only had 17,800 pounds of fuel, this was 6,200 pounds less than normally needed. Without fuel to achieve lunar orbit, somehow they found enough to return to Earth.
Oh Jarrah, if you would have spent more than 10 minutes researching this, you would have found this particular diagram, which is the Apollo 13 mission profile. Notice there were 4 mid-course corrections, 1, 2, 3, 4, and then of course the trans-Earth injection. So how long were those burns, I hear you ask? Well, let's find out. It's not that hard to check. This information is available all over the internet, Jarrah. The first mid-course correction was performed using the service propulsion engine for 3.5 seconds. The second mid-course correction burnt the descent engine on the lunar module for 34.2 seconds. The trans-Earth injection used the LM descent engine, and this burn was for 4 minutes and 23.8 seconds. The third mid-course correction, using the LM descent engine, burnt for 14 seconds. The fourth mid-course correction was performed using the lunar module reaction control system, and this was used for 11.5 seconds, a grand total of just over 5 minutes of firing for the lunar module descent engine.
But I leave that for a rocket scientist to calculate.
Please do, Jarrah. Leave it in the hands of the professionals. So where has Jarrah gone wrong? It's quite simple, really. A free return trajectory does not require entering lunar orbit.